So this is a long-awaited episode. We have one of my favorite guests that I've been trying to ask for a while to get on here. I think many will know him and his face and his name from the industry. But Spencer, I think it would be interesting for you to give a little bit of background. I think everybody knows you from Schüco, just given your
Yeah.
design and technical background. But um, you went to facade school, which I think is super interesting and something that a lot of us stateside here don't get that opportunity. So just dig into a little bit of how you got into the industry and then what drove you to really want to dive that deep into the technical side of things.
Yeah, sure. So I actually graduated from architecture school in 2011. I went to Mass Art up in Boston, and when I was there, we did the solar decathlon project, and that was the opportunity for me to really learn for the first time about the importance of energy efficiency in building construction. And on that like student project, we pursued passive house certification, which was like on top of doing a design build project as an undergrad, also going through passive house consultants training was like a pretty big undertaking and expansion of my understanding of like how facades relate to energy efficiency. So that's how I kind of got introduced to the niche topic of facades. After that, it became kind of a goal of mine to work in the industry as close as I could to high performance, facades to improve the energy efficiency of buildings. And kind
Let
of the
me
outlook I had on it was like,
let me
you could,
interrupt here
yeah,
before you go there. At that time when you were really in this stuff 5 or 10 years ago, and it
yeah,
wasn't as call it relevant, where now all these words, energy efficiency, thermal performance, passive house, everyone wants to
yeah.
talk about it around sustainability. But at that time, did you always feel like a little bit of an outlier, or you were like really keen on this topic that no one wanted to talk about?
Well, it's funny. You kind of have to look at the history of it. So, in the US, this whole energy efficiency in residential construction that we're very familiar with today, it's kind of like the kind of standard, especially in the Northeast, really emerged out of like the solar home concepts of like the 1970s and like trom walls and like these kind of old school approaches to creating like you know, energy efficient buildings with like a lot of like kind of wild mechanical engineering concepts with like thermal mass and like lots of solar exposure in one area. So, where I was going to school, we had kind of a community in the Boston area of like people from that generation. So like Mark Rosenbaum was like a mentor to, some of our team. And so, there's like this niche group in that area. It's like very comfortable with this stuff. But the difference was that what we were trying to do is really take like this German approach, which was this whole kind of passive house, methodology where you're calculating all of the heat flow and like, how much energy is being generated inside the structure and how much you're losing. You're like doing a detailed analysis, and at the time, like in 2009, it was one of the first passive house trainings offered in the US. I think I was in like the third official training that was offered for consultants training. So it was definitely new. And like the concepts were well established in Germany, but like no one really knew how to like implement it in the US because a lot of the like window technology and like, thermal break technology, even some of the air barrier systems were based on like products that were developed in Europe. So this is where I got introduced to Schüco because, when we did this project, it was like, well, what do we do with windows? Like the windows become part of the heating system, right, in a passive house building. So you need to really tightly control like the solar heat gain coefficients and like the heat loss through the assembly. And at that time, the best options were to import windows from Europe. And so that's how I got exposed to like, European tilt and turns and like super insulated frames and like triple pane glazing. And, it was like through that experience that I saw that there was like this gap at that time of domestic manufacturers not really having the right solutions in place and the codes, not really being to the level that they are now, encouraging like thermally broken construction. And, when I say codes, I mean like specifically the Boston, like New York, like Northeast markets, right? Colder climates, or, also enforcing kind of like higher performing U values on window frames. So that's how I got into it. And then, I started working for Schüco about 10 years ago. And what I realized when I got into the facade industry kind of more formally is that a lot of the knowledge that we have in practice comes from just experience. Like there's very few academic programs globally that address facade engineering as like a formal topic. And there's different like ways to enter into it, right? Like you have obviously the structural engineering side of the industry where a lot of people come from the structural engineering side, but that's like building engineering. And then they kind of narrow their focus into facades. And then there's like the building science looking at more kind of mechanical engineering concepts, but it's more general for, opaque wall assemblies. What I was looking for was something more specific to glazing and fenestration engineering. And that's how like I kind of got like led to going to Germany. Because in Germany, like the idea of facade engineering as like a discipline is, I would say, more established, right, than it is in the US. Like it's more of a formal practice where you can actually go to school for it, and there's like a more of a career track in that direction.
So would you say the facade consulting community is very prevalent there, or is it a culmination of all? Are the facade contractors more sophisticated than the industry as a whole?
Yeah, I would say it really starts with like the architectural education, so one of the, in my opinion, like the great shortcomings of architectural education in the US, and this is kind of like a pretty broad statement, but I'm going to stand behind it, is that there's kind of a lack of like real technical knowledge in most programs. Like you focus on like design and you address technical topics, on a kind of minimal basis. But when it comes to like construction detailing, right, it's usually not something that's like prevalent through the entire experience of like an architectural curriculum. It might be like a focus in like studio for like one project or one elective or something. And what I've noticed working with people in Europe, architects specifically in Germany, is that there's much more of an emphasis in incorporating like facade detailing and even engineering into the curriculum, because I guess the approach is that you know your requirements, your building code requirements are inclusive of all of these topics that maybe in the US we would consider more in the realm of like a facade consultant scope, right? Where you're dealing with like detailed thermal bridge calculations or U value assemblies, of wall systems and framing systems. But, in Europe, in Germany, like that's just part of what you're having to do for like the project that you're designing, even like a single family house, right? Like new construction needs to meet like passive house standards. So I think there's like a different mentality and requirement just as a baseline, and there's other examples in the US that are sort of in that same vein, like going towards like, working with like stretch codes or, regional like specific requirements for like, HERS raters or something like that, where like a single family home is going to have like an energy model, but it's not as nuanced. It's not as detailed as what you have when you look at like the European methods for doing these calculations. So, I think that's a big part of it. And in terms of the consultant community, I mean, I haven't done a lot of work in Europe, so I don't know the exact differences, but it seems like a lot of the technical knowledge is still like held in the architectural community. And there's not as much of a need for like facade consulting in the way that we know it, like in the US market.
And so how do you think that's reflective of as built buildings in Germany and some of these other markets? Can you go into the projects and really feel and see the difference?
Well, I think there's a different value proposition overall, in terms of like what the facade is within the scope of the budget of the project, right? Like, I think it goes back to the kind of code requirements, like as a baseline, your requirements are going to be much more aggressive in terms of thermal performance and utilizing that building envelope as part of the sort of overall heating and cooling strategy of the building. It's not just about like, here's your code minimum, and then we're making up any additional requirements for comfort with auxiliary heating or cooling systems because we have cheap energy, right? It's not like that. So, I think the requirements are really driving a lot of this, but there's more of an emphasis on like the craft of fenestration, specifically in Germany, right? Like,
Well, and we're going to kind of get to the Schüco
yeah,
stuff and how it evolved to that, but it sounds like a lot of these principles, are kind of at the baseline what the Schüco brand was built around. I mean, what I want to get into is I remember being with you in Connecticut and seeing some of those automated parallel push out vents, and even like the incorporated blinds within the unitized assembly, automated crank hardware, and all these things that we kind of dream up as like science fiction here in the States. And then I'll go and see a building, on the internet where they implement all of this in Europe. And you think to yourself, like, hey, how do they have the budget to do it? And I understand the passive house standard and being able to justify more spend up front and on the facade to see an ROI. But when it comes to more of the technology side of things, um, I guess, is it just part of the culture and practice and maybe the expectation to allot more money towards the facade in that market?
Yeah, I think so. I think the kind of qualities of what defines like a valuable building, right? I mean, we're kind of really going off into like hyperbole here a little bit, but I think it's true. Like if you look at a lot of the kind of what would be considered like high quality or high value buildings in Germany specifically, or what adds value to a building, it's the facade is treated as something that is worth the investment, right? It's a long-term like part of the function of the building, of its identity, but also in terms of like its efficiency. And the shading elements that are on the outside of so many of these projects are also really important. And again, it's coming from this idea of optimizing the performance, right? Like shading on the outside versus the inside. There are huge trade-offs with how much you're actually able to improve the efficiency of the building. If you locate your shading elements on the exterior, you have a much greater impact on the performance of the facade. So that's expressed, and invariably when you do that, you're adding complexity to those assemblies, but in a lot of ways the complexity becomes justified because it's also backed up by an industry that treats the building and installation of fenestration as really more of a craft than just kind of a basic trade, right? Like a lot of the companies that are fabricating windows are also installing them, so there's also more of a direct connection between the producer, in the factory and the work that's being executed on site. There's like, maybe you could argue in that way, like a greater level of quality control and control over the whole process. Like obviously here, in the US, it's a very different market, right? Typically you have different entities involved in the production of glazing and the installation. And so there's consequences to that, And that's not to say that every project in Germany follows this, but it's more common than not to have that structure.
And so, what was that experience like coming back from schooling and being here stateside? And you've had the um, opportunity to work in New York City and some very high end markets with some very high end clientele, not only in New York City, all over the country. But what has your experience been like having a very sort of sophisticated upbringing, call it, in the industry, and then trying to come here stateside where we're a little bit ancient in some of our building practices,
Yeah.
and if that's been frustrating or how that's been over the course of your career?
I think it's resulted in is the biggest focus that I've had so far is in taking kind of the best of what, Schüco can offer as a European system provider and engineer, right? Manufacturer, and adapting it to this market. Because the challenge is always that a lot of the European fenestration products, they have a lot of unique benefits that, add a lot of like value to a project, but they're not they're not designed from the ground up for this market. So, the goal becomes, how do you make those adaptations? How do you integrate all of those like benefits into kind of the situation that we're in with this market, So, a lot of the work that we've been involved in since I returned, and since we've, been active in New York doing these kind of, very custom projects, is in making these modifications to the system to, address like US construction tolerances, for example, or to address installation methods that are very different than those that are conventionally seen in Europe, right? And still getting the benefits of like oversized vents, right? Or the thermal performance, or, the acoustic benefits that you can get. And so that's really been the goal. And you have to approach it that way because you can't just force like the European methodology, into the process. Like it's not going to work here. You're going to create way more problems, by doing it that way. So it's more about adaptation, has been the key focus.
And do you think that the European market, this is a very general question, but is trying to adopt any building practices and principles from us? Where do you think we excel stateside,
Yeah, I mean, it's interesting, right?
if
Like a lot.
anything?
That's a good question. I mean, it's not one that I've really pondered in much detail. I think there's definitely like a sentiment that like the German facade engineering community on the manufacturer side is like this kind of like powerhouse, globally. And it's true, but the reality is too, we have major, players in the market that are US based, and they operate globally. I mean, some of the, world's most kind of iconic and complicated buildings and facades are done, here in the US. So, I think that the big difference is really about operating kind of at scale, right? Like just the performance requirements for some of these high-rise buildings, that I've worked on in New York are, in terms of structural demand or sizes, they're exceeding a lot of the limits of what you would typically find like in, Central Europe, right? Or, exceeding those parameters in a lot of ways. So, I think there's kind of an innovative element to solving those problems on like a custom job, and dealing with like superstructure, tolerances that are way beyond what you have, in most projects in Europe is like a whole nother set of challenges that you have to solve here. How relevant that is for the European market, I can't really say, but I think that there is some value in, overcoming those challenges. Yeah.
Yeah, and I think one thing I've really learned about is the European model of having all these kind of keen boutique fabricators all over the country,
Yeah.
and how it's different from here. I mean, as a installer, manufacturer, engineer, we a lot of times we really own the whole process, and so we're liable for everything. And so when detailing and designing systems, we have to really think about how is it going to be installed and what are the on-site implications. But when you're so far removed on a system design level to the actual as-built condition, do you think that that's become the norm here and that's what causes a lot of issues on site?
Yeah, I mean, I think that it can lead to it. I mean, what I've learned is that, in general, the simpler your overall strategy is, let's say for installation, the simplest form of the detail that you can make is generally the best approach, right? And that's not usually congruent with what you see in Europe, right? And so, I think that there's a lot of value to, trying to reduce complexity, um, to mitigate like some of those issues that can happen when you're having multiple parties involved in the chain, or the other thing that's very common is like multiple skill levels. Like you might have a fabricator who's like operating at a much higher level than the installer, and the installer has to, kind of accommodate this complexity of a, European system, and it just that can create issues, right? So, I think that that's one huge thing that, is super important for this market and, has a lot of relevance in any market is just the simplification.
If when you I know you have a grew up, your dad was a general contractor, so you have kind of an appreciation for the trades and the installation construction side of things, but also as a very technical person, you're a trained architect, and I'm not an architect, so you can see things from more of a probably aesthetic design standpoint, and couple those different lenses and have an appreciation for it. But when you talk to people outside of the purely either glazing or fenestration industry, even if it's GCs or developers in the industry or like masons or whatever, do you think people diminish the complexity of glazing and just look at it and say, it's just a window, pick it up off the shelf, or, just send me some glass? When in reality, I mean, I've seen you now review and chime in on details and, the making sure that you have an adequate structural silicone bead and making sure all the adjacent materials are compatible and how it's going to manage water and all the nuance that goes into it. So
Yeah.
do you think there's just a disconnect between what actually goes on in the industry and then the rest of the world?
Well, I mean, I think you kind of have to look at it almost like a niche industry, right? Within the kind of broader ecosystem of architecture and construction, because, in the US residential market, right? Like a window for most purposes, is a standard size, something that's mass produced with a nailing flange, right? Like this is the world that we live in. And so, that kind of like application has nothing to do with structural silicone, right? It really has nothing to do with glass engineering as well. And so there's like a massive divide between like that segment of the market where you're kind of in a mass produced like standardized like set of details and methodology, versus something where you end up with like real structural demands on a glazing system, or you know um, different sight lines, or even extruded aluminum in a lot of cases being something that's more in kind of the commercial space, and is got it's got a whole different set of like skill sets behind it that I would argue like a lot of you know residential carpenters like don't have a lot of hands-on experience with. And so I think that divide is like kind of creating this like situation that we have in the marketplace, where now like most of that specialist knowledge is allocated to like commercial applications, where you have to qualify this stuff. And the devil is in the details, right? Like that's the reality. Like these small like moves in like detailing and installation or system configurations, they might seem like trivial, but they can have huge consequences. I mean, the facade has so much potential risk, right? Like it is the weather barrier for the building, right? And so, you have to, I think you have to understand that like when you look at a section, especially like a window section, it's interesting to kind of like talk to people who don't have any experience with like aluminum extrusions. Every part of that profile has a purpose. Every single piece of geometry has a function, right? And that kind of like mode of thinking needs to be applied to like the full scope of the facade. And so I think that, that's like a very different approach than just like throw the window in the opening and tape it, and screw it in place. So
Well, that's what I think the industry's become. Everything seems so interchangeable, and not
yeah,
recognizing that like not only does everything within the window work in tandem, but then everything adjacent to it works in tandem. And
yeah,
so like having an idea of how the window is actually going to sit in that brick opening and behave with one another. And that's what I think the passive house principle or idea encompasses, that you have to look at everything holistically and not as all these individual components that you're just slapping together.
yeah. And that's, it's really important because if you really understand the physics of heating and cooling buildings, right? The facade is like a huge part of that process, of that chain of, heat transfer from inside to outside. And a lot of the kind of approaches, for code compliance and even NFRC, as much as I appreciate NFRC, like it doesn't really address in detail what the impact of your glazing system has, for the project specific configuration and site conditions, and so that kind of thinking that comes out of Passive House, I think, is really relevant because, like you're saying, it does set it in context and show you how it's connected to kind of the greater scale of the project. How your window U value is affecting your insulation thickness in your wall. What the trade-off is there, for example, right? Like it is all connected on some level in that way.
Yeah. Um, yeah. So, all right, I'm going to ask you a loaded question. What is
Yeah.
to kind of now move things along or later on in your trajectory? What does this whole Skyline Schüco move mean to you, and what are the opportunities in the industry that you see?
Yeah. So I think, just to address it directly, what's happening here with Shuko now, you know, essentially joining forces with Skyline, right, is that we're getting the ability to really improve the way we're operating in the US, and I think utilize a lot of the kind of like proven methods and like overall like position that Skyline has, in the New York market, and apply that kind of thinking to the rest of the country. So, in my mind, what it means on a baseline is that we've got great opportunity to do what we were doing before, but much more effectively. And I'm really excited about what it represents because we've always been operating in the U.S. kind of as an entity that's bringing the knowledge from Europe, trying to disseminate it, trying to adapt it to this marketplace. And we've been working to support our local fabrication partners around the country, and we're doing that kind of from this perspective of a European system supplier. And I think now, for the first time, we're really going to be doing it from the perspective also of like a domestic system supplier, right? Like Skyline having its own history of developing its own products and selling those for applications in the US, and being very, very familiar with this adaptation of like European window technology for the US market. And so to me, like, we're being able to utilize like all of that knowledge and experience and now apply it to like our bigger network. So I think it has a lot of great potential to kind of improve the way that we're adapting our systems for the market. That's how I see it.
Yeah, and I think there's so much to be learned
Yeah,
from one another. And when I say that, Skyline and Schüco aside, from me and you aside, from the European methodology and the domestic methodology. And I think um, we both can improve. And even to say like some of these details that I like to share that aren't necessarily Skyline details, like getting into some of the nitty gritty topics of things that people don't want to or don't like addressing publicly that have to be addressed regardless on these projects over and over and over again. It just goes back to this like hole in our market around there really is no way for people to learn other than spending years and years and years on the job. I mean, I have
yeah,
some college students sometimes reaching out, like, what are, I don't know, resources, areas that I can go to do more, to just learn more and capture more of the industry. So there's just like huge notion of tribal knowledge that's sort of like hidden in a
yeah,
bookshelf, behind a closed door that certain companies don't want to share. And
yeah,
regardless, I think you still just continue to see the same problematic issues come up over and over again on projects. I mean, you and I were talking last week about terrace doors, and like you can
yeah,
design a perfect terrace door that on paper works, and you can throw it in the test chamber and have it pass 15 PSF. But as soon as you start playing with your adjacent inside and outside conditions and changing your paver dimensions and where the finished floor goes
yeah.
and how the system is managed, like that can just change the performance night and day.
Yeah, I mean, it's really critical, like on one level to understand like where the product sits in its kind of performance threshold on its own, right? Independent of any site condition, let's say like laboratory test condition, right? But none of that matters if it's not, integrated correctly into the building, right? And, it's so important that, the kind of overall methodology, incorporating the context that everyone understands on the project team, what the potential consequences are, and that they're all committed to kind of realizing that shared vision. And too often you end up in situations where, different trades kind of check in and out of the process as the building is built, and they sort of hand off, the results of their work to the next trade that then needs to deal with the consequences if there's something that, isn't right. And look, this becomes like the source for like really contentious situations on jobs and like disagreements. But, at the end of the day, we all have like the same goal, right? Is to make our buildings successfully constructed and perform, as specified, and make our clients happy. And so if you kind of look at it from that lens, everyone has in sort of a way like an incentive to make those translations from one trade to the next like as effective as possible, so that you have minimal issues, because invariably, like if the concrete is out of tolerance, like wildly, right, on a sill condition or something for a terrace door, the concrete has to be adjusted. It's like it doesn't just end there. Like you have to
You
go
don't
back
just
and
adjust the door on site.
yeah, it's not like I can cut my door and I mean you can make a new door, but no one's gonna wait for that, or pay for it, right? So it becomes this whole, point of challenge, and you can address it by ensuring that your requirements are communicated up the chain, upstream to the trade before you. And so they know what they need to provide. And then that's clearly defined. And then even downstream of you, if you're coordinating with finishes that are coming in afterwards, making sure that you understand what those requirements are and then kind of synthesizing everything, that's,
Well, yeah, I think that, and as I'm thinking through this, I think the issue is that the industry or all these little sectors, whether you're, I'm trying to think, a metal panel supplier or a window supplier or just a roofer, all these things are just products that, some builders just trying to slap together to make a building that's weather tight
yeah,
that he can dry in and get his tenants in.
yeah,
And like the importance of there's just so much significance on how they work succinctly with one another. And I don't know if you would think that sort of is the role of a general contractor to make sure all these things are properly coordinated and due diligence is done. But like you've taught me the significance of, or shown me rather, like putting a lot of these interface details into a 3D configuration so you can really understand it. Because unless you have that ability in your brain, which I don't, looking at a 2D section is limiting, And you could try to imagine how the vertical and horizontal intersect, but until you see it and say, we have a flaw right there, you're not going to find that out until you're in the field.
Yeah, and that's, I think that's where, like, if there's one thing I've learned so far, I mean, look, I've been doing this 10 years, right? There's other people in the industry who have way more experience, but there's been something consistent, which is that if you bring the issue to the forefront to the team, like the general contractor, in a way that they can understand, right? Even if it's not related to your scope, but you're early on in a process, maybe you're developing the project, even schematic design development, if you're in a design assist or just getting early access to a job, the sooner you can kind of share your concerns about perimeter conditions or adjacent construction and potential conflicts, the better, and you have to get ahead of it because it's so much easier to mitigate it during design, pre-construction, than to deal with a field fix, right? And it's never fun. Like even in design coordination, like, changing drawing sets and requalifying engineering, like it's a huge pain, right? Labor's involved, you have multiple submittals involved, but it's always easier than doing the field fix, right? Because once you're in construction, you're on the clock, like aggressively on the clock. And so the to your point, like the challenge I've seen is being able to like effectively communicate this, and you're right, like even a lot of general contractors I've worked with, you can tell them and say, hey, like you need to make sure that, your concrete has this tolerance at this condition. It's like, well, why? Like show them why. It's like, here's the consequence if you don't, if it's not going to be this way, this is the problem we're going to have, and kind of raising awareness on what those consequences could be early on, I think is really effective, because the GCs, they want it to go well too. They don't want to have headaches, in the field.
What
So
portion of the projects you've been involved with have had performance mockups?
I'd say probably like 2/3 of them.
It's a
Yeah.
lot. It's a lot.
Yeah, and they can be simple, they can be from, I mean, when we say performance mockup, there's the laboratory mockup with like a full battery of testing, but then there's like, an on-site mockup could be considered a performance mockup, with some field testing as well,
So let's
right?
talk about field testing. So
Yeah,
assuming every project for the most part, commercial setting is going to have some form of hose testing, chamber testing for air and
yeah.
water. Do you think the window manufacturer contractor should have the right to know what units are being tested prior to the testing?
Well, I mean, I think not for random field testing. There's a real value to it, and we also do this with production testing. Same concept, right? Like the laboratory mockup, the PMU in its kind of formal definition is a way to kind of give the facade contractor the heads up that they need to like get everything settled, right? But ideally that happens before the installation, right? So for field testing, really it's a QC procedure is really what it is. You're ensuring that what you've provided and what's been installed is kind of what you committed to giving the project and selling to the project, right? So, I think keeping it random is incredibly important, and I think you have to ensure that you're getting the kind of um, the truth, behind the results of the test and the outcomes, as nerve-wracking as it may be, for the facade contractor. Um, yeah, I absolutely think it's critical. Yeah.
I mean, I have Elliot on here all the time, and he lives in the field testing and mock-up world. And,
Yeah.
I had a lot of years of watching him and his team test projects that I was a facade consultant on. And of course, when I
Yeah.
was a consultant, I'd say, of course, random. And when I was a subcontractor, I'm saying, no, we should be able to, tune it up a little bit before they
Yeah.
test it. But having him on a couple episodes ago, which was like, this was like one of those aha moments to me. He calls it a torture test. He said the test is designed to put it under the most extreme conditions, and let's find any of those pinholes or any area where we're going to have air leakage, because we're not just trying to pass the test for 15 minutes and make sure this lasts a year. We want
Yeah.
this to last 20, 30 years.
Yeah.
Fine. Okay, everybody can understand that. But when you're in that moment and you get that email from the general contractor, the test failed, and all the fire alarms go off, all that, we're going to back charge you this, we're going to go after you this,
Yeah.
you're going to do
Yeah.
this, and legality, all this. It's that's when I think people can start to get a little bit irrational.
Yeah, I mean, the interesting thing about this is that, I agree, like the testing on one level, in many ways, nothing against like the good people on the AMA or ASTM committees who are writing this stuff, because I appreciate all of that very much and I agree with it. But the reality is it's the standards are like not reflecting reality, right? It is a stress test in a lot of ways for the system, for the whole assembly. And so, what becomes interesting with that is like how do you qualify how far to set, like how high to set the bar? Like what's appropriate, And if you look at what's happened in the facade testing kind of, protocols and procedures, and even in the requirements for facade performance over the past 10 years, the bar just goes up and up and up. Like, it never goes down, right? So it's like it's only becoming like more stressful, you could say. And so the onus is on, the glazing contractors to kind of understand what that means, and it's, on one hand, it's really good to have better performing buildings, to have more resilient buildings. I think that's incredibly important, for kind of long-term performance, but then there's also examples of buildings that, were built in the 70s and the facades are still there. They're not great thermally, right? But like they still exist,
So
they,
somebody's still going in there.
yeah, so I mean, it's kind of like, okay, well, if you look at like the overall history of these standards, like they really haven't been around for very long, right? This kind of technology hasn't been in use for that long relative to kind of the age of some buildings that are out there that are still in use. So, I think I think despite that though, like there's kind of this goal of creating like higher performing buildings, right, going forward, and that the buildings are going to get better and better. And how do you have to rationalize that with test standards? There's no other way to kind of qualify that than through testing. I can give you a simulation that says this is how it will perform, but ultimately, like, you know, your simulation is occurring in like best case conditions, right? Like, as we were talking about, like the result of your project is not the result of your engineering. It's the result of your engineering, your production, your installation, the coordination of all of these different parties and trades.
Well, that's the
And
that's the other thing.
yeah,
Like in curtain wall, even forget operable windows, because operables are tricky to execute, especially in large sizes. And we could probably both point to a lot of areas where we know the leak may occur. But just in a unitized fixed curtain wall, the amount of quality control you're relying on in the field at your chicken head splice joint seal,
yeah,
at every single stack joint location, if they get sloppy or if they don't let the
yeah.
silicone cure properly or they miss a couple and those units are stacked on top, you're never going to get to it again. So what are some modes of failure that you've seen or you've heard of in a fixed unitized curtain wall? And then like at that point, how do you even fix it?
I mean, it's a great question. Like, there's kind of this like silly, saying right in the curtain wall industry, like you try your best and silicone does the rest, right? Like I don't know if that's been on their podcast before, but um, you're pointing to the absolute reality, which is that in some assemblies, and not even unitized curtain wall, like other products as well, like access becomes like a major issue once you've installed products on a facade, right? And so, ideally what you have figured out with your system design are like potential modes of failure. There's like every system has weaknesses, right? And I think it's a little difficult to say like generally unitized curtain wall failures across the board are related to X, because there's so many different variants out there, so many different site conditions. But I think what's common across them is that going into a project, kind of where your weak points are. And so you start with those, right? And anytime you're in a situation where you're doing, fixes or you're having to remediate, it's always about like problem finding, like you need to figure out like where, like if your assumption about your system weakness is relevant to the conditions that you're facing in the field, and this is why like field testing is so important in process, because if you get to a situation where you've installed a majority of the building and then you start field testing and then you're finding failures that then become systemic, or maybe you can't isolate the problem, it becomes a real challenge, because then you end up pursuing this kind of like quest like investigate the units. And that might involve, modifying the system in the field, opening up profiles to try and get better visual access into the drainage systems, putting, cameras in place so that you can see during field testing what's happening inside with the gaskets, because there's no other way to really know what's going on, right? And that becomes like, that has major consequences on like what does the product look like after that, and then what, more importantly, is going to be required for the balance of the building that's already on the wall, right? So stack joints are critical. I mean, I would say the kind of more critical areas are usually anywhere where you have a splice condition of any kind, right? Splices are by their nature high risk because you're relying on someone in the field and their craftsmanship and attention to detail and their application of sealant and dissimilar materials, or maybe even the same material, but they're creating a joint in situ, right? And so environmental factors play into that, workmanship plays into that, and you have to have consistency, right? And that's tough, right? That can be tough to pull off in those situations. So usually those are the drivers, but there are all kinds of reasons. I mean, even unique elements that have penetrations or structural outriggers, or, if you're modifying like drainage planes to get certain architectural reveals, these can all contribute to modes of failure with those types of systems. Yeah.
And I think just identifying or highlighting, I mean, you said it, you're repeating a lot of the, things I and others have been pushing on this podcast, which has been the significance of like, if you're going to test regardless, why push it off till the end? Like
Oh
at
yeah.
least get the most bang for your buck.
Yeah, you get the most bang for the buck, and also have like a QC procedure. QC is like so critical, when you're in these situations where the project is being held to a really high standard of performance, and you have an aggressive schedule, right? The last thing that,
Also, when you say that, not just if it like, because I'm thinking about it from both sides. I'm thinking about it
yeah,
like, okay, hire an envelope consultant, have them monitoring, shop monitoring, have them field monitoring, have them,
yeah,
develop and insist on the testing protocol. But like, how about just hiring a subcontractor and vetting their internal QA/QC process, and like making sure the IGU fabricator has a very thorough
yeah,
QA/QC project? Because the more like the earlier on you can catch these issues in the float glass plant, in
right.
the IGU fabricator, in the curtain wall or window wall manufacturers before it gets to site. Because think about, as the glazing subcontractor, if I receive bad glass, if you just had eyes in the float glass facility beforehand, you
Yeah.
just save so much time.
Yeah, it's amazing to me, especially with glass, like how a lot of the QC happens after the glass is built and delivered, right? The glass
Yeah.
shows up and then it's inspected and then it gets rejected. It's like, man, like talk about a waste of energy. Like, whoa, and I sort of understand, like from a supply chain perspective, like, okay, maybe it's not feasible to have someone in Europe or China or wherever the glass is being produced, but yeah, I think it could be so much more effective, if you get to it earlier, with all of this stuff, because the thing that I find, and this isn't really specific to glass, but the longer you wait in a process to go before you start testing and doing the QC, once you find the problem, if it's later in the process, what invariably happens is that you have more constraints. So the way you can fix it, the solution now just has like way more constraints around it, and it limits your options, and that's what can be a hard pill for a lot of people to swallow in these projects, because you're so far along that like you don't have time to go back and replace a window or replace an anchor, or you have to deal with what's there. And it's a compromise. And every good compromise, like no one's happy, right? All parties are dissatisfied. That's the best compromise. So I mean, that sucks, right? So getting to it earlier just gives you more flexibility with like how creative you can be in solving those problems. And I think it's absolutely on point. Like, not everybody wants to make that investment though. And facade consultants, they do a lot to push the industry in that direction. But the fact of the matter is, like, at the end of the day, it's on the contractor to fulfill those like responsibilities. It's like the facade consultant just says, like, here's the problem, right? But then like the contractor has to fix the problem. So, it's good that they're part of the process, but it's like these QC procedures, this kind of like culture of like wanting to stay on top of it and address things early, really needs to come from the suppliers first and then trickle down to the installers and to the whole team. And that's in kind of kind of highest aspirations, best case scenario. Realities are jobs are constrained by schedule, budget, resources, right? We deal with these limitations all the time, but how much easier would our lives be if we could have more people who were committed to kind of finding the problems up front and solving them earlier? It would be a much less stressful industry to work in, I would say.
Yeah.
Yeah.
On that note, this was fun. I think
Yeah.
we should do a round two and have someone from Germany on.
Yeah,
But,
definitely. Definitely. No, it's
thank
been
you for
great.
hopping on. And
I appreciate the invitation and really looking forward to our collaboration going forward.
yep, until next time. Thanks,
All
Spencer.
right.